go to the second presentation. Good morning, everyone. This is Team 5. So today we have Robert, David, and I will present you our project. As you can tell, we built a new type of bike stem light, which has a universal fits on all bicycles. So what is a bicycle stem? A bicycle stem of the bike is the stem of the bike is the component that connects the handlebar to the front fork. And our goal is to integrate a headlight into the stem, so it can also works as a power bank for devices. And if you ask, why are we doing this? I can tell you that most of the lights of bicycles nowadays has many downsides. There are two types of lights in the market right now. One is with great illuminations, the other one being only for decorations. Lights with great illuminations are always big. I mean, the light itself as well as the battery. So when you carry a considerable amount of weight on one side of your handlebar, it will never give you a good riding experiences. Some of the product requires users to strap the battery onto the bike frame, and due to the weight of the battery, it could move around a lot. When it hits the frame, it leaves a mark. And if it's too loose, it will fall off eventually. So our objective is to integrate the headlight into the faceplate. And so the center of mass will not be interfered. We hit the battery in the stem body, so it will not move around and is being well protected. We made the battery not only power for the light, but it also can work as a USB port coming out of the stem and charge for whatever device you have. And our fourth goal, as you can see, is to make it sleek and light and appealing to cyclists of all levels. A product has a reversible entry direction on the stem to reduce weight. As you can see on the bottom picture right here, the black thing is a stem from Specialized bicycles. I believe it's used for road biking. And so this stem, it represents most of the stems in the market. And the faceplate, you can see, is very slim, which is on the very right side, but the back is very bulky. However, because we wanted to implant a headlight into the faceplate, so the faceplate will then be very bulky as well, and that adds a lot of weight, as shown at the very bottom of the picture. So by making a reversible entry, the backside can be slimmer and it reduces a lot of weight. Okay. Can you go to the timeline, Robert?
We should be on the timeline now.
Okay. So this is our Gantt chart for timeline. We have all the tasks listed on the very left-hand side, and the black box being our initial schedule, and the red axes are the actual completion date. As you can see, we did run a little bit ahead of ourselves for a few weeks, but however, all goals were met at the end. And on the very right side, we've divided the works to each team member, and we've all completed our schedules.
Hello, everyone. My name is David. I will be talking a little bit more about the electronics. So we decided that we were going to go with a 26500 lithium battery cell, mostly because in the market, to fit our purposes, there wasn't really a lot of choices. I know, like, we were considering getting a 9-volt, but those are square batteries and they won't fit. And yeah, so the 26500 cells is the one that fits into the stem, and it's also not too long because the bicycle stems are not that long either. And this one seems to hold the most amount of power for the smallest amount of size. So we basically got the circuit boards. Like I mentioned, one of them was to charge the battery. You don't want to charge a battery too fast or discharge it too fast because, lithium, it's pretty finicky. So that's what the circuit boards are for. So these are just some of the diameters, 22.3 millimeters for the controller. A charge time is approximately 3 hours to charge. If you charge it at 1.5 amps. Runtime is approximately 4 hours at 400 lumens. And we have a cutaway here so you could see what it would look like sitting inside of the stem. And yeah, just some more pictures, some more measurements.
Yeah, so to go over the physical parameters of the stem itself, the stem that we actually built came out to 105 millimeters, which is actually like, that's pretty standard length for most bikes out there. You're going to have about 100, 110 millimeter stem or so. And that's from the center of the steer tube to the center of the handlebar. And this also gives us, like with the battery, we have the room to shorten. Technically, it's about 20 millimeters, but then we need about 5 millimeters itself for like the circuit board. So we have 15 millimeters to shorten. So we can come down to a 90 millimeter stem, which is also kind of fits in that very common range. And then we can also go out to 120 millimeter stem, which is like a little bit on the longer side, but that basically allows us to get a huge fit window, which is super important when it comes to like proper bike fit. And so with on top of that, we also did a 10-degree positive or negative. So you basically, what you could do is you can flip the stem around and then have either the stem point up to get a higher handlebar position or point down to get a lower handlebar position. So it's like on a hybrid, you'll have a lot of times like a little bit higher position for comfort. And then on a road bike for like aerodynamics or just, going faster, you'll have a lower position. And then what we did is we actually cut the faceplate at the same angle as the steer tube. So regardless what direction you flip it, when you put the steer tube on, when you put the faceplate on right side up, the light is always pointing at the horizon. And by doing the flip, that gives us about 36 millimeters of a stack change from positive to negative, which the stack is basically how high the handlebar is in relation to the bottom bracket. And so again, huge fit window. Most bikes come with about 30 millimeters of spacers from the factory. And so it allows us to basically go negative all the way to the top. And then if you need higher, then you go positive all the way at the bottom. And then you can work a huge range of fit in right there. Oops. So go ahead and David with the LED.
So the lens and LED were pretty much got out of a flashlight. The diameter is 22 millimeters, thickness 14 millimeters, brightness 600 lumens. So when you first start it up, it's pretty bright. Let's see. So it runs for about 4 hours before it dies, and it's a Cree J5050 high efficiency LED, 5 watts max. The one thing that we did notice with these LEDs is they get really hot. So that's something, the proper heat dissipation was something that we really had to work out on that. But yeah, so really good LED. And yeah, we can move to more pictures on. So these are some pictures of a product being used. As you can see, you have the black stem, the battery's built inside of it, and this is just like a standalone without it on a bicycle. We were thinking of putting it on a bicycle, but it would be just more for looks. Plastic, 3D printed plastic, it's not very durable, so I don't think it would be a very good physical product. But yeah, I mean, the aesthetics and the hardware components are there. You can see the charging port. It's built in through the back right here. Another thing I wanted to mention too, it's that right now this is our first iteration of like this final design. But for the future, we do plan on making some sort of way to charge it as you pedal. But just time constraints and things didn't really allow for that. But yeah, I mean, some pictures of it in action, and
a few minutes that we actually had it working before the LED burned out, because this is plastic versus like if we were to actually take this into production, it'd be on like a 6061 alloy, and so we'd get better heat dissipation than what the ABS provided us. And so again, like that was part of the plan, right? Like we knew that we're not going to have enough heat dissipation through the ABS itself. We just wanted to make sure that we could test the theory, make sure that it works. It works. Okay, great. Let's snap some photos, and that's it. So. All right. So next steps, this is beyond the class. What we would do is we take this bill of materials, right? So it's like all of our bolts or different charge controllers or USB output plugs, wires, your threaded lens closures, the lens itself, the lens cover, any O-rings, basically every component of the stem. We'd hand that off to like a supply chain team, and then the supply chain team would go look at sourcing that from different locations. And again, what we did is, like for the lens, we did take the lens itself from a flashlight, because we know that that's a component that already exists, and that's something that we would actually be able to source, right? Someone else can source it, we can source it, right? So the final bits to the class is basically getting through the process of, bill of materials and making sure that fitment's good, making sure that the function, everything that's there is good, and then being able to pass it off to an actual production team, right? So that's something like with the production team, we'd basically, as engineers, we would work with them to make sure that the actual product that they're producing is to our spec that we built it at. Because a lot of times factories like to, take what you say as a grain of salt and build their own thing. I have that actually experienced firsthand. So, yeah, again, this is all things that that are beyond what the scope of the class was. Casper?
Okay, so conclusion. Sorry, my internet's probably lagging. So when you change the presentations, I probably see it seconds later. So